examples like this, exercise 36, page 72, multiply through. Now, if I was doing this, I don't often bother to look too much for the common denominators. I just say, okay, I'm going to multiply by 5 and then multiply by 3, simplifying as I go along. But in this case, it might be worth, actually it hits you between the eyes. The 5 and the 3 both go into 15, so multiply through by 15, and then you'll get there in one hit rather than doing it step by step. Does that make sense, James? So if I call this equation 1 and this equation 2, if I multiply 1 by 15, I'm going to get 15x over 5, because I multiplied by 15, plus 2 times 15 is 30, y over 3 equals 49, because the 15's cancel. Just pause that there. How does that make it easy? Because at this point now I can say, right, 5 goes into 15 3 times, so that makes that 3. And 3 goes into 30 10 times, which makes that 10. So now I don't have to worry about the 5 and the 3. I've done it in one hit. So therefore, 3x plus 10y equals 49. And then I do a similar thing with equation number 2, multiply through by 7 and then 2. And I'll end up with a similar problem to the ones you've been looking at already. Don't forget, 7 times 0 is 0. Okay, not 7. So I'll leave you to maybe finish that one off and have a look at some more from that exercise. I really want to focus on this one though. Let's look at this. Now, the way the book goes through this is that it makes a substitution. X is what we're after, the value of x. But if I think of equation number 1, let's look at this. This could be thought of as or 2 times 1 over x plus 3 times 1 over y equals 7. That's another way of writing equation 1. Do you remember that one of the first sessions we had, dividing by something is the same as multiplying by 1 over it. So how could I rewrite the second one? 1 over x minus, what could I write instead of 4 over y? Right. 1 over y times 4, yeah. Equals minus 2. That's another way of writing equation 2. And then, what you do is, you let 1 over x equal something else, a. And you let 1 over y equal something else, b. And then you rewrite the equation 2a plus 3b equals 7. And a minus 4b equals minus 2. And suddenly it looks like what we've already been doing. And you'll end up with an answer for A and an answer for B. But we want X and Y. So what do I do when I've got A? Invert it, yeah, to get back to find Y. So it's quite a clever little trick, isn't it? Okay. We use another substitution to make it look easier. And that's basically what they've done in that little work problem and then carry it on through. Okay. However, we could have done something else. So let's look at this one again. So let's rewrite these first two equations. 2 over x plus 3 over y equals 7. I think they've done that to get round some algebra, really. 1 over x minus 4 over y is minus 2. What I could do is do what we did at the beginning. I don't want x underneath, so multiply by x. Okay? So if I take equation 1 and multiply it by x, what I'm going to get 2 plus 3x over y equals 7x. And then I'm going to multiply 1 by y to get rid of the y. 2y plus 3x equals 7xy. Now what I want to do is actually make a substitution. I want to get x or y on its own. And that involves something that often happens in things like this. If I've got x's on both sides, say I wanted to get x on its own, I get all the terms involving x on the same side. So therefore, 2y equals 7xy minus 3x. I've subtracted the 3x from both sides, got the x's on the same side. Now I use factorising. Because x is common to both, I can take x outside a bracket on the right-hand side. 2y equals x into 7 minus 3. Sorry, 7y minus 3. Then divide by 7y minus 3 to get y on its x on its own, yeah? Divide both sides by 7y minus 3. 2y over 7y minus 3 equals x. Confidence with algebras comes in this one, doesn't it? There's no steps here that we've not done before. It's just you trying to use them to help us. And now substitute that back into one of the original equations. Instead of y, I'm going to write x rather. I'm going to write 2y over 7y minus 3.
How come then when you get over you take out the bracket?
I could have left the bracket there. I just didn't bother with it because there's nothing else there.
But then when you're putting it back in, because the brackets there, you have to
If the bracket's there, it means, and there's nothing else there, it means 1 times that. So that actually means 1 times 7y minus 1 times 3, which really don't need the bracket. So if the bracket's on its own, you don't need it. I need it here because it's times by x. Yeah. Well, it makes it awkward, doesn't it? So let's have a look at it. So substituting this back into the original equation, 2 over x plus 3 over y equals 7. So substituting this into the original equation, maybe I should write that. Substitute into 1. So instead of x, I'm going to write that. If x equals that, what does 1 over x equal? That's a semicolon. What does 1 over x equal? If I invert that to get 1 over x, no. To get 1 over x, think of this x, it's like x over 1. So I invert this to get 1 over x, so I invert this, and I get 7y minus 3 over 2y. So instead of writing 2 over x, I'm going to write 2 times 7y minus 3 over 2y. Plus 3y equals 7. And now I've only got y's. Not straightforward, I accept, but I've only got y's. I've now multiplied 3 by y to get the y's at the top, and then I've got an equation involving y I can solve. So there's a few more algebraic steps in there, but you can do it using substitution. Do you remember I said that the substitution was the more general method that always works? And there it is working. However, I think you probably agree, having looked at that, that that's quite a neat little trick to let 1 over x equal a and 1 over y equal b, and then go from there, okay? Maybe you would like to just follow that through because the algebra is useful in its own right there, seeing those steps, and maybe try and finish that off if you're feeling confident, see if that works.